we will publish the whole event on the Sunrise Project website and YouTube channel, so you can also watch it again if you want, or share it to your contacts that maybe are interested in seeing and watching the event. So we will start the recording. And good morning, my name is Sara Tana. I work for a company that is partner of the project that is called Warrant Hub, and in Sunrise Project we are in charge of the communication and dissemination. And today we are organizing this event together with Lure Derra, that is coordinating Sunrise Project. This event is called the Second Stakeholder Workshop because it's a follow-up of a previous event we have organized last year in Copenhagen. So I'm very pleased to welcome you. And during this event, our aim is to explain you the main results we have obtained in this project and also to ask for your feedbacks. So please, if you want to say something, you are more than welcome. If you want to ask a question to our speakers and to our audience, please write in the chat, or if you are here in presence, of course, you are free to do it. So I just opened this event and I will give the floor to our first speaker, that is our host, Lure Derra, so Angelica Perez, that is our project coordinator. Angelica is a chemical engineer. She works here in Lure Derra since 2009, and she has coordinated different projects, lots of projects, but mainly two in the recycle field. And Sunrise is one of them, and of course, you maybe already know that is related to PVB recycling. But if you already doesn't know what the project is about, please listen to Angelica Perez's presentation that, of course, is about the project and the results obtained, but also a presentation related to the sorting system, sustainability assessment, and application of REPVB. So, Angelica, the stage is yours.
Thank you, Sara, for the introduction. Okay, I hope all you can see and hear me well. First of all, thank you for coming today to this second workshop. We are very happy because we see when registering people from the first workshop, so we have maintained your interest. This is good, but also we have seen new faces, so that's always good. So I'm going to make a presentation about the project. This time more related what we have been done until now, because the project is in the end. We have remaining 6 additional months. So the idea is to present some idea of what the reason of the project, in case you don't know, and also which are the status in terms of results we have obtained. So okay. This, in case you don't know, although I think most of you know about the problem, but I am sure that there is new people in the works today. This is the reason of the project. This is our waste focus of the project, which is laminated glass and PVB. So this laminated glass is obtained by bonding 2 glass layers using a polymeric interlayer, which most usual is based on polyvinyl butyral. So this waste, the laminated glass, is not really the problem concerning the glass, because this waste is from construction and automotive are recycled by glass recyclers around Europe. But here the target is to recover the glass, and PVB is considered a waste in the glass recycling process. There is not much percentage of recycling, and most of this material is incinerated or landfilled. So you can see the piles of laminated glass accumulated for recycling in recycling plants, and piles of PVB waste after extracting the glass. So the problem is, okay, why PVB is not recycled? So there is different challenge with the PVB, mainly for circular recycling. I mean, when this project was much focused in circular recycling, trying to improve the recycling of PVB and the quality to go to the same application in laminated glass, even we manage also with other applications. For this application, there are several challenges. First is the glass content in the recycled PVB, which will worsen the optical properties. Then there is the aging of PVB, not only by the use, but because sometimes for recycling, this PVB or this laminated glass is exposed at outdoor conditions to facilitate the separation of the glass. So this polymer is degraded. And then the last one is that there are variability of PVB interlayer composition. Sometimes there is not PVB. It could be another polymers, and different types of compositions could also suppose a mixture at the end, which create haze and turbidity. So that's the reason of this project. That's why this project started in 2021. And we are 20 partners. This project is granted by the European Commission under Horizon 2020 work program with a contribution of 8 million approach. And Lourdes is the coordinator. This is the video of the project you can see in the website. I am not going to put it again because we have some limited time today. Okay, and this is the structure of the project. It's important to know, in order to understand which is our status now, that this project was divided in four main parts. One was related with the recyclers and waste provider, which gives the information about the needs, which gives the materials and define what is now in the sector. Then we have this part of the project, which has been the main part of the project related with our main focus, which is the development of the multi-sensor tool for sorting the quality of PVB. So here, a main part of the work has been related with the design of this sorting system to the definition of the techniques, and then the classification and the posterior mechanical and chemical recycling. So first we develop this sorting system, then we treat after sorting according to the qualities in the mechanical and chemical process. And this has been more or less 2 years in the project working, and now we are more related with these two final phases, so which are related with the processing of the recycled PVB after sorting in different formats for final applications in laminated glass, again, for construction and solar applications. But also other applications that could be minor, but needs to be also considered, like in energy, in batteries, and also in coatings and textiles. Okay, so now I will try to go result by result about the main results of the project. Our main aim was, there is the challenge I have explained before are related with composition and degradation. So the idea in the project was to develop a multi-sensor sorting tool, which can identify these parameters or some parameters related with composition and degradation previous to shredding the laminated glass. So we can put its full glass in a different category according to the composition, and after that treat by mechanical and chemical processing for removing as much as possible the glass. So this was the main part of the project, the development of the multi-sensor tool. The methodology for development these techniques and identification of these techniques was to make kind of line characterization of the different parameters related with the composition and degradation, and then correlate these with different spectroscopic techniques which could assess online these characteristics. Finally, these spectroscopy techniques which were selected were Raman, near and transmittance. In the case of the Raman and near techniques, these were both of them assessed for identification of the composition, if it is PBB or not, and the plasticizer. And then we have an integrated proof head for measurement of optical properties related with, transmittance, but also yellowness and haze. So based on these techniques, after the definition of the methodologies and organization, it has been constructed a prototype. It's a prototype which allows fast inspection if we consider this is a prototype. But this could need some increase in throughput for industrial capacity, of course. But just now this sorting capacity is higher than 100 nanometers per hour. Could be decreased this time and increase the through output, because just now we are considering two systems that could perform for the same. So the time needed for one sensor and the other could be decreased if we only put one sensor in the system. And this prototype could be adapted for industrial requirements. Also, in terms of the haze, it has been developed a method also in a project for measurement the haze, not according to the conventional standard, but which allows to measurement haze online in a process. And the accuracy of this method has been very good. So that's related to the multi-sensor tool. And this is the final full line for the sorting that we will visit after the speeches of the different speakers today. I will not explain a lot here, or something very brief for the online, because then all of us we will go to the plant. Basically, you can see here the multi-sensor. Is the mouse here? This is the multi-sensor, where we feed the piece of the laminated glass, because now we are feeding a piece as a prototype sensor. And here we have different auxiliary systems. So we have a cleaning system, because we need to only with brass, but we need to remove the dust of the glass in order to have a good measurement of the spectrum of the optically throughout the glass. And then this is a preparatory module, because just now we have to take one piece of the laminated glass. And then after the sensor, the automatic line starts here with the cleaning, the sensor for classification and measurement, and then there is a conveyor belt with some actuators that directly put in the different big bags according to the quality. This is easy. So we will visit after, and you will see the working of the line. So I have explained that we sort according to composition and quality. More in detail, which is this. We are sorting according to 3 categories. For these categories, we use these sensors, the measurement of these sensors, but these measurements of these sensors has been also, this data has been useful for learn some artificial intelligence algorithms that allows the real-time assessment of the composition of the PBB. So the first within the first category, we have first category, which is a high-quality interlayer, which is detected based on optical properties, the haze level and the yellowness level. And then we have category 2, which is a higher degradation level according to haze and yellowness, and a third category, which is a non-PBB, so the polymer, or it is not classified material. So within a category, the aspects of related with the compositions within category 1 and 3, and within category 1, we have different aspects related with composition of different types of plasticizer, are determined with help of these artificial intelligence algorithms that predict based on the data they have been learning on about all the characteristic issues worked on in the beginning of the project. So according to these sensors, according to these algorithms, we have some results that, okay, we have been comparing NIR and Raman as both trying to determine the composition, and these are equally sensible to identify PBB from non-PBB, and also in identifying the presence of the main plasticizer, that it is 3-ethylene glycol oligoesters, and there is difference between minor plasticizers. It is more accuracy, the results of the Raman. Okay, in terms of prediction of the other aspect we have tried to assess during the project was try to identify the plasticizer content. Here, okay, we have started with some data, and okay, there could be good results because it's a matter of learning the algorithm, but we have determined that okay, we need to improve the accuracy with more data for the learning phase. So what is important here? Okay, both NIR and Raman can work for the discrimination of the main plasticizer and the type of polymer. We could choose one another. In the reality is that NIR is faster than Raman, so probably for industrial applications could be a better option. Okay, so after sort these categories, what we make is make a mechanochemical treatment. Okay, usually laminated glass recyclers makes a mechanical recycling. So we introduce here an additional chemical step to remove a higher part of the glass. So we have optimized this procedure for improve the removal of glass in the high quality categories, which is more important. And okay, this chemical treatment consists in different washing steps where different agents are eliminating the glass and breaking the links between the glass and the PBB for removal this glass. More or less data we have obtained depends on the source of the waste. So it depends if it is construction, it could need further cleaning. But if it is automotive waste, the results of the glass in the final waste, in the final flakes of PBB are below 0.05%. And okay, if there is aging in the initial process previous to the mechanical process, there is okay data about below 0.1% of glass. So okay, I go to the next part of the project, which is related. Okay, once we obtain these flakes, what need to do to go again to applications. So here is the work we have been developing in the last 1 year, like 6 months, and it's related. Okay, on one hand, University of Athens working in reprocessing of this PBB for again giving the capability to have new lives without degradation, without thermooxidative degradation. So they have been working with this recycled PBB and comparing. Okay, if we go again to extrusion, to heat degradation, we see that this polymer will be degraded very fast because the mechanisms of degradation. And okay, we see that melt flow rate and yellowness increase a lot. So they have been working in different antioxidant formulations to be added to this recycled PBB to inhibit the degradation and ensure that it's stable in the processing and and then it can be stable also in the next use. So these are some results of the project with different antioxidants. Okay, it is clear that the antioxidants are working in the recycled PVB and that are needed, because if not, we increase the degradation. We are now trying to adopt these lab scale formulations in the industrial scale with a Biomi partner. It has been started to make the first tests. And one challenge here, if we go again to transparency aspect, is okay, all the additives we incorporate does not affect the transparency of the PVB. So that's is part of the project in terms of processing PVB for final applications. Then the project is working also in produce with these recycled PVB flakes, these pellets, stabilized pellets, and then with these stabilized pellets go to a film product again and check if this is of enough quality. Okay, we anticipate also in the previous workshop that we could need a mix with virgin PVB. And because, okay, we see in the beginning, in the first test, that when we use this mechanical chemical recycled PVB from the treatment in Lourdes, the results were that these were much clearer film than currently recycled material in the market, but still needed to improve the optical quality. So just now we have been working with mixtures of virgin and recycled PVB, processing this in pellets and then in film by Biomi. And this has been tested in laminated glass for construction sector and for solar applications. We have made some first tests. And now Ariño in construction and Met in solar are validating these characteristics. So in terms of these laminates produced by Ariño, okay, we still have to improve our optical clarity, because okay, we are obtaining haze values between 3-5%. Considering we are mixing with virgin PVB. So still we need to improve this. We are going to work in this 6 months, try to make modifications to improve a little bit more this, to see where is our limit. And then what we have already achieved when we mix with virgin PVB is this adhesion, the mechanical properties and the adhesion, that these are okay. Okay, this is the Pummel test, make Ariño with some of the samples of the project. And then for PV panels, Met is comparing the performance of, here is more complicated because we have to compare with another different polymer, which is EVA. And in terms of transmittance, okay, the transmittal could be very similar when comparing with EVA. And they are making, but they have to make a lot of characterizations to be usable in solar field. So according to damp head test, in the first 250 hours, the samples work very well, both without edge sealant and with edge sealant. But after 500 hours, the samples without edge sealant starts to become foggy. So what we are seeing is, okay, if we use PVB, we need to make some modifications to the design to introduce these sealants to avoid increase of humidity. And that's about the lamination applications. Then the project also works in other with other formats. We work in other applications with dispersion and dissolutions. Here, some are applications that were already known and were a potential end for recycled PVB already in the market. Other are related with different applications in textiles and batteries. So here, these are the applications on textile sector. So here, Next Technology Textile is working in application of this recycled PVB as coatings on textiles for ultraviolet protection. So they have used this material in solution and in dispersion, containing crosslinker for increasing the adhesion to the textile. And by spraying and drying method, they have applied on textiles. And they have obtained good results in terms of homogeneous, colorless, and durable coating, also maintaining the flexibility of the textile. And they have also incorporated UV absorbers for making this functionality, this additional protection to the coating. And what we can see, here are the results of the different textiles and coat with this with the values of UPF, mean value, representing the protection versus ultraviolet. And only the coating increase the protection, and with the cross linkers, with the UV absorbers, we have good protection values, and this not affect the textile. And the other application is the one here developed by Radici company about the application of the recycled PVB in carpet production. Here, starting with these flakes, they work in the solution of these materials to create an alternative latex product, which can be used to bond the two layers in the carpet, the aesthetic and backing carpets. And currently they are working in laboratory tests on different fibers, natural and synthetic, and they are starting to have results according to some specific properties needed for this carpet, which is the tube lock results, which is the resistance to remove some fiber from the carpet backing. There are different results in terms of some, depending, these are different type of fibers, of carpet fibers. And some values could be good, others should need to improve, but at least we see that we could have a chance to some type of carpets in the project. And this is regarding application in lithium and sodium ion batteries. I have to mention that, of course, if you have questions about the applications, you can ask after that to our partners. They are here present and also online, so they can explain you better than me this part. But coming to the applications in batteries, the main idea or the main works up until now has been trying to substitute this use PVB to substitute polymeric binders in cathodes, in anodes and cathodes of the batteries. And on the other hand, trying to use this recycled PVB in polymeric separators. So the work developed in the project has been first starting with virgin PVB, to check how it's working, and then trying with the recycled PVB. In the case of substitution of binders, when working with virgin PVB, it has been able to substitute the fraction of the standard PVDF or PAA with this PVB, and up to contents of 20-50%, and these are effective both in lithium and sodium ion batteries. And then it has been incorporated the recycled PVB, and also can be used as well, displaying excellent specific capacity and zero capability, but with low initial Coulombic efficiency due to secondary reactions of the plasticizers contaminants. So this need optimization, but it's working also. And in the other application, as polymeric separators, on one hand, first with virgin light and thin PVB-based membranes were prepared by cross-linking with the isocyanates. And these membranes were tested as electrolyte separators in lithium-ion batteries with an electrolyte uptake as high as 221% and electrochemical stabilities up to 4.7 volts, which is high. And then we have been working in to use this recycled PVB. And the procedure was optimized also for the preparation of the membranes, forming dense elastomeric membranes, and also compatible with metal lithium and stable open cycling. So, okay, there is also work pending for these applications, but results are interesting, and okay, there could be some chance to use recycled polymers in batteries. And that's related to applications. Finally, I go to the environmental and techno-economic analysis. We have been analyzing both the recycling process, and now we are more related in the project with the application side in terms of assessing the environmental and economic in the applications. These final results of the applications are not presented here because we are still developing the application, so we will have final results in the next 6 months. But in terms of the recycling, what we have been done in the project is to compare this additional step we are proposing in Sunrise sorting and the additional mechanochemical cleaning of the PVB. After the conventional process of the recyclers. So we have been comparing this with, which is our Sunrise scenario, Sunrise 1, with other scenarios, which are the incineration of the PVB or the landfilling. And okay, we have these results summarized here about a percentage of carbon reduction. Okay, we see that the Sunrise scenario in comparison with landfilling or in comparison with the production of primary PVB or waste to energy incineration and landfilling, okay, we have considerable reductions of carbon footprint. Also, there are reductions in other environmental categories, and these are quite high. In fact, here we are considering not only the recycling process, but going to a final reusable product. So here is included also the part of processing for pellets and film product. Okay. Okay, this is about technical outcomes. About technical outcomes, the strategy is the same. Compare these additional steps with the current scenarios. In the current scenarios, we have a cost for incineration or for landfilling. In the recycling process, we will have also a cost, but okay, we'll try to have a benefit if we go to the market. So, okay, we make some first estimations according to the prototypes of the project in the first graph where we have, okay, with our prototypes, we were having, okay, more repercussion, okay, with mechanical, but because we were working with prototypes here, which have a limited capacity. So we make some numbers with higher productivities, and we reduce this cost. Also, thinking that here, in this case, chemical could be the highest repercussion. But we are in prices that are comparable with the market of PVB flakes. So these are the market price for foil PVB. For flakes, we are finding prices in the market around 1,000 euros per ton. And okay, these granulated recycled PVB are higher. Of course, these granulates are not for film applications. So we are now in the project refining this course with the new data of the technical part in order to see, okay, our processes, which how much increase the cost if we go to final formats. I mean, if we go to pellets for film, if we go to film, we go to dispersion and dissolution. So this is our next work we are developing now, and we will have the end results in the next 6 months. And I think that's all. This is our team. This project has 19 partners, and all the partners are making great contributions, and without this partnership, I think it will be difficult to achieve results. So thanks to all the partners for the work and also for preparing the slides for the presentation. And now I would like to give the floor to the attendees to make questions, comments. So please. Question in the chat. Okay, thanks. The question is that if the laminates are 100% recycled material or blend with virgin material, our last results are blends of recycled and virgin material. Yes, they are not 100%.
We have a question. Okay. Just a moment. Good morning.
Thank you very much for the presentation. I just wonder if you have all the data regarding the analysis of this recovered PVB in terms of percentage of OH, plasticizers, and so on.
We make different characterizations. We make for each batch, we have making for checking the accuracy of the sensor in terms of we have classified. We make an MR to determine the plasticizer type we have. Sometimes we don't have only one plasticizer, we have mixtures. But okay, we can identify with NMR these plasticizers if we know the types. And then we also, with TGA, we determine the percentage of plastics, the content of the plasticizer. And okay, glass content measurements we make, humidity measurements. Okay, with NMR we can determine a OH content also and a lot of parameters. So we take some batches and take some measurements, not in all the batches, but in some of them, yes. I have another question online. Thank you. Okay, about the blend ratio, okay, we have been working with different percentages. We have been working with 50-50 and 60-40. We are in this range of percentage.
Someone else? No? I think we can go on. So thank you very much, Angelica. And we will give you the floor to our next speaker that is connected online, and she is one of our partners. Welcome to Claudia Labs. Hi, Claudia.
Hello.
Hello, we can see you. Many thanks for being here, even if online. In the meantime, we upload your presentation. I just give an overview of who you are. So Claudia Labs has been working at the German Institute for Standardization, DIN, since 2005. And she's responsible for the project management of various standardization projects at the national, European, and international levels. Her role is to assist experts from diverse interest parties, including industry, government, NGOs, and university, to find the best solution when drafting standards. So many thanks for being here. Claudia will talk about the launching of a CN workshop agreement on characterizing polyvinyl butyral recyclates. So Claudia, if you are ready, the stage is yours.
Thank you very much, Sarah. Welcome, everyone. So yes, I will be explaining you shortly about the standardization activities we've been doing in the Sunrise project, and namely the launching of the workshop agreement. So next slide, please. So firstly, let's shortly look at what standardization activities we are doing and what is the aim of those. So the aim is to support the market player to use the recycled PVB in the various applications. And generally, research projects have basically two different possibilities to involve in standardization activities. One is the launching of a SEN workshop agreement, which is abbreviated as CWA. And the other one is the liaison with existing technical committees, SEN-TCs, to give input to standards and ongoing standardization projects. Next slide, please. So what is a standard? It's a consensus-based document that is approved by a recognized body, in this case, at European level, for example, the SEN, the European Committee for Standardization, or at international level, it's ISO, the International Standardization Organization. And a standard provides rules, guidelines, or characteristics for activities of and their results, and it is based on the consolidated results of science, technology, and experience, and therefore reflects the state of the art. And standardization in general promotes the knowledge and technology transfer from research to markets, especially making innovative know-how widely used and known. And it also networks with all the relevant actors. Next, please. So at European level, we have 3 different standardization organizations. I start from the bottom, which is ETSI, the European Telecommunication Standards Institute. Then we have CENELEC, which is the European Committee for Electrotechnical Standardization. And we have CEN, the European Committee for Standardization. And CEN does basically standardize all those topics which are not electrotechnical or telecommunication. Next. And CEN and also CENELEC, or also ISO at international level, provide a platform for the stakeholders in the different specific areas, which are called technical committees then, to come together and reach consensus at European level for CEN or for ISO at international level. It helps to ensure that the system respects the World Trade Organization's principles for transparency, openness, coherence, and consensus. And it supports the established technical bodies, so the technical committees and also the working groups under those technical committees in developing their standards and pre-standardization deliverables. Next. And there are basically 4 different types of deliverables. The first 3 are drafted in technical committees, and those technical committees are made of different experts, which are sent to the European standardization by their national standardization bodies. And the first one is the European standard, the EN. The N stands for norm, which is French and German for standard, which is a highest standard where you have full consensus on how to see one of those topics. Then the technical specification, the SEN-TS, has either not full consensus or the topic is so new that the experts say we'll start with a technical specification before drafting a European standard. And then there are technical reports, SEN-TRs, which are supporting documents, not having any requirements in them, but giving data. And then besides the technical committees, there's a possibility to individual interested parties, you need at least 3 different parties, to develop so-called SEN workshop agreements, abbreviated as CWA, in workshops. So you come together for a workshop and meet 4 to 5 times and then draft a SEN workshop agreement. And in Sunrise, we have started the SEN workshop agreement process, and I'll go into more details about that in the following slides. So the workshop concept in itself is a very flexible working platform with light procedures and the direct and voluntary participation of different stakeholders. And the participant basically decide on the working arrangement. If at a later stage, the intention is to have the CEN workshop as a basis for a European standard, then it makes sense to also use the working arrangements from the standardization process. It's open to any company and organization within and also outside of Europe, and it includes at least one public process, meaning a commenting phase, and possibly two phases where the public may comment. And it is quite fast, meaning that a document can be published within 10 to 12 months, whereas with the normal standardization processes, it takes 18 to 36 months before you have a European standard published. Next, please. And so the workshop agreement is the final deliverable. It is voluntary in its application, but you can refer to it when you use it. And the content may be anything from technical specification, guidance material, best practice, information, whatever the consortium or workshop participants deem sensible and necessary. The format is most of the times just pure text with tables and figures. Can also be computer code or multimedia files. And as I already mentioned, it can be the basis for a European or international standard at the later stage, which we actually have the intention that our CEN workshop agreement will be used as a basis for European standard later. So next. So now specifically for the Sunrise project, the intention is that the recycled PVB can be used in different applications. And so as Angelika already mentioned, it's for one, the safety glass in buildings, road vehicles and railway applications. It's the photovoltaic applications, PVB for peelable coatings, carpet production, and also in batteries. So the recycled PVB, which come out of the recycling line, need to meet any requirements those applications have. And the idea of the CEN workshop agreement is to help make sure that those requirements are communicated between the market stakeholders. So next, please. So the new workshop we initiated has the title Plastics, Recycled Plastics, Characterization of Polyvinyl Butyral Recyclates. And its kickoff meeting was held on 12th of April at DIN in Berlin with a hybrid option. And we had participants from within Sunrise, where Loredera is chairing the workshop and Politecnico di Torino is vice chair. And Dean is holding the secretariat. And then we also have some organizations and companies from outside the Sunrise project who are interested in the topic, as like Eastman and Kurorai. Next, please. So what is the scope of this CEN workshop agreement? The document defines a method of specifying delivery conditions for PVB recyclates, and for this, it gives the most important characteristics and associated test methods for assessing the recyclates intended for use in production of semi-finished and finished products. And it is intended to support the parties involved in the use of the PVB to agree on specific aspects they need for their applications. And it does not cover the characterization of the plastic waste or any traceability topics. Next, please. So the core element of the CEN workshop agreement is basically a table with all the characteristics relevant for the PVB recyclates and for the different applications. And as there are different applications, we divided the characteristics in two types: mandatory characteristics, which are required to characterize the PVB recyclates in general, because it's necessary to know those characteristics for all the applications, and then in optional characteristics, which are only needed for specific applications or customer needs. And table 1 also includes the associated test methods. And then the idea is that in addition, each batch of recycled PVB shall have the information of the product name, intended suitable applications, and also, if possible, the origin of the material, where it comes from. Next, please. And so here you see the overview about the life of such a CEN workshop project. It is from the proposal stage. You have then a project plan and then an open commenting phase on that project plan, and then the kickoff meeting. And we are right now in the CEN workshop agreement development. And then comes an optional second commenting phase, where the CEN workshop agreement, as it is intended to be published, is published as draft on the CEN-CENELEC websites. And then the public can comment. And for our workshop agreement, we are intending to have this voluntary commenting phase, and it is usually at least 30 days and foreseen for September and October this year. And then there will be another meeting of the workshop participants to discuss any comments and then finalize the document, so that the CEN workshop agreement should be available by the end of the year, latest at the beginning of next year, also on the CEN-CENELEC website. And the underlying document explaining how this process works is the CEN-CENELEC Guide 29, which is also linked here if you are interested in looking at it later, because of course you can have the slides after the workshop. Next, please. So how long does CEN workshop agreement exist? It is usually valid for 3 years, and then the workshop participants need to decide whether to confirm it for another 3 years, to revise it, or to withdraw it. And maximum validity is 6 years, and then it has to be withdrawn or transformed into another deliverable, such as, for example, a European standard. And the maintenance of the CEN workshop agreement is in the responsibility of the workshop secretariat. However, if there is already a technical committee which is interested, they can undertake the responsibility to ask the workshop participants after 3 years whether they want to confirm or revise the workshop. And actually, at any time during the lifetime, so any time between just published to after 6 years, a technical committee may decide to transform the CEN workshop agreement into a technical specification or a European standard. And both technical specification, European standard, and also technical reports are valid forever if they are confirmed regularly, basically every 3 to 5 years. So the idea is that optimally, the CEN workshop agreement is at some point transformed into a European standard, so it can be kept and used further on. And in case another standard is published which contradicts the CEN workshop agreement, then the CEN workshop agreement needs to be withdrawn. Next, please. Regarding intellectual property rights, just as with all European standardization, the copyright is actually owned by CEN, the European Committee for Standardization, and all participants assign the copyright of their individual contributions to the CEN, and that does not preclude the holder of the original holder of the copyright to exploit his or her own contribution for its own purposes. For example, researchers cannot still publish papers, obviously, as long as it doesn't affect adversely the standard. And especially for SEN workshop agreements in the research and development domains. They can be made available for free on the SEN Senelec website. And that's also what we intend, that this SEN workshop agreement can be then downloaded for free from the SEN Senelec website once it's published. So end of this year, beginning of next year. Next one. And just for rounding this up, we also have a liaison with CENTIC 249, the Plastics Committee, and especially with its working group 11, the Plastics Recycling Working Group, namely because they have published a standard series called basically exactly the same as we have called our SEN workshop agreement, Plastics, Recycled Plastics, Characterization of, and then they have for different standards for different plastics, such as PP or PE or PVC recyclates. And so the intention is to offer the SEN workshop agreement once it is published to Working Group 11, hoping that they will then take it up and include it in their standard series as a European standard. Yeah, that's it. Thanks.
Many thanks, Claudia. Does anyone has any question for Claudia? I don't see any question in the chat. I don't know if someone here in Loredera has any question for her. But if you want, of course, you can think about and maybe ask question later on. So, okay, it seems we don't have any questions. So, Claudia, many thanks.
There's
maybe in the chat.
A chat just came in. So if you want to be part of the SEN workshop agreement, how does that work? You just email me that you would like to be part of it, and then the other participants need to agree that you can become a part of the workshop, and then you can then you will get all the information about the workshop and the next meetings. And the next meeting is planned for the 17th of June. And as we just started, it is still a good time to join if you're interested. My email address is in the presentation.
Thank you very much, Claudia. Thank you again.
Thanks.
So we give the floor to our next speaker that is here in presence, and it's not a partner of Sunrise Project. So many thanks for having accepted our invitation. I give the floor to Jorge Arroyo Villanueva. You can, you can stay here. In the meantime, we upload the presentation. I just give an overview of his bio. Jorge Arroyo Villanueva is an industrial engineer and doctor from the University of Zaragoza. He spent 8 years working in the Department of Mechanical Engineering at the University of Zaragoza, where he completed his doctorate in renewable energy and energy efficiency. Now he works as project manager at the CIRSE Foundation within the digital industry team, and additional is the technical coordinator of another EU-funded project that is called REDOL, and Jorge will talk about this project now. So many thanks, and the stage is yours.
Thank you for the introduction, and thank you for the invitation. As I explained, I am Jorge Arroyo. I am the technical coordinator of the REDOL project. I work for CIRSE Technology Center. Before the presentations, I wanted to show you who we are. We are a technology center located in Spain, in Zaragoza. It's a city 150 kilometers from here. We work in those business lines, from renewable energy to circular economy. We have 4 pillars. The persons is the third pillar. We are near 300 employees in 2023. Other is the research. As you can see, last year we started 14 new projects from Horizon Europe. 4 of them are coordinated by CIRSE. We have also an important income of transfer services to private companies. And finally, we work a lot in the education. We carried out more than 200 training courses during the last year. Come back to the project. This is the agenda I am going to follow. First, I make an introduction to the REDOL problem, the solution we are trying to get, the impacts, objectives, the methodology, and some generalities of the project. And in the last two sections, I want to show some examples of activities we are carrying out in the project. One is activities in the construction and demolition waste value chain, and other is the development of the basis. We are establishing the basis for the development of a circularity hub in the region of Aragon. So REDOL is the acronym of Aragon Regional Hub for Circularity, demonstration of local industrial urban symbiosis initiatives. It's an Horizon Europe project. It was granted in this call, in the Cluster 4 Green Transition call. It's an innovation action. That means that we are, as you know, we are going to develop some demonstrations, and we are analyzing the replicability. The budget of the project is more than 17 million euros, and 14 of these budgets are funded by the European Commission. We started the project in December 2022, last 4 years, and as you can see in the map, most of the partners are based on Spain and in the Aragon region, but we have represented 12 countries of the European Union. Among the partners, we have large companies, small and medium enterprises, technology centers, public institutions, and non-profit organizations. So we form a strong consortium. What is the problem we are facing in the REDOL? In 2020, we generated 500 kilograms per capita in the European Union of solid urban waste, and we just recycled the 45%. To address this issue, the European Union released the Circular Economy Action Plan, which fixed some challenging targets for recycling in 2030. You can see here some example of targets. It's 65% of recycling is solid and urban waste, 70% in construction and demolition, and 75% for packaging. In REDOL, we are proposing the redesign of 5 value chains: packaging, plastics, construction and demolition waste, textiles, and waste from electronic devices. And we plan to make 5 activities. First, data gathering and characterization and alignment between the different actors of the value chains. We are developing some technologies for the management and processing of the solid urban waste. We are working also in digital tools for the monitorization of the different value chains. We plan to make an overall demonstration of the technical, organizational, and social innovation by redesigning these 5 value chains. And we want to make some impact analysis, and we are performing social actions and analyzing the replication strategy. And this is the potential impact of the REDOL technologies in the city of Zaragoza. While in 2020, most of the waste ended in the landfill, the idea is for 2040 to move 140,000 tons of this solid urban waste to recycling, and this can generate savings on the greenhouse gas emission of 280,000 tons of CO2 and generating an economic activity in the region of 14,000 million euros. This is also the impacts that the technology developed in the REDOL can have in the different value chains. You can see the increase in the recycling rates, for example, in packaging up to 70%, in plastics 55%, construction and demolition 80%. In the textiles, the technologies can recover 100% of the textiles collected in the waste managers. And for electronic waste, the idea in which most of the metals are recovered, the idea is to use more economic processes and cleaner processes. Below you have the evolution of the landfilling rate plane for the area of Zaragoza. You can see how the landfilling rate is decreasing up to the 140,000 of tons I mentioned before, while the recycling rates increases in this following this progress. We have 5 objectives endeavable. The first one is to develop and demonstrate novel management system and processing technologies for solid urban waste. The idea is to obtain recycled secondary materials which can be used as feedstock for the production of circular products. We want to contribute to enable the achievement of the zero solid urban waste landfill approach for the city of Zaragoza. We want also to study the replicability in other cities of the European Union. And the 5 objective is to ensure that dissemination and exploitation, adapting the commercialization and business models to this circular approach. This is the methodology we are following. Don't let this slide blow your mind because there are a lot of interaction between the value chains, especially because there are different subproducts and materials which can be processed in different lines. The approach is quite similar to the Sunrise project. We have the 5 value chains: packaging, plastic, construction and demolition, textiles, and electronic waste. In the first line, we have the technology for management and collection and sorting of the waste. As you can see, most of the technologies are based on artificial intelligence and robotic arms or another kind of automation. In the second line, we have the processing and recycling technologies. We have, for example, for packaging, we are developing a selective delamination of multi-layer packaging. In the case of construction, working with green soil policies and formulation of recycled components for cement. In the textiles, we work with we remove the elastane of the textiles and work with glycolysis processes to produce polyester yarn. And finally, for electronic waste, we work with the valorization of the PCBs using deep eutectic solvents. And finally, below in the graph, we have the circular products, in which we are going to use the materials produced from the previous steps. In this case, we are developing a lot of circular products. For example, we are working for automotive parts, recycled cement, reinforced wood particle boards, geotextile, flame retardant materials, etc. This is a picture of the partners. We have divided, we have assigned one role for each one. As you can see, you will see later in the correction in the base of the hub, it's important to have this role. First, we have the waste manager that most of them are located in Zaragoza or Aragon at least, except in the textile value chain, in which we work with Alia, which are located in Italy, in Prato, which has a tradition in textile, and are quite more advanced respect the recycling of textile than our city. The second point, we have the technology center as companies, which are the technology providers. We have some partners in which we will demonstrate these technologies. And finally, the end users, which are the partners who are developing the circular products. We have other transversal activities, digitalization, with some partners working in the digitalization of these value chains, the creation of the circular economy, which we have the Zaragoza Council, which is an important partner. We have also the university and different research centers of the region, and the dissemination and exploitation activities. As I mentioned before, the replication is important. We have three partners from Europe acting as replicators. We have Amsterdam in the Netherlands, Bornholm in Denmark, and Prato in Italy. And we are planning we are trying to apply some of the knowledge acquired in the Redol project and extrapolate this for these cities or areas. They are quite heterogeneous because Zaragoza is a city of 700,000 inhabitants, and for example, Bornholm is an island and in the small. So we will need to adapt to the different size and conditions of these replicators. The next step, I wanted to show you some of the results. It's impossible to show you in 20 minutes everything we are doing. So I have focused in the construction and demolition waste that I explained before. There are some lines for sorting, for processing, and finally the circular products. In the case of sorting, we are working with Casale, who are a waste manager for construction and demolition waste in Zaragoza, and ICCS, which is a technology center from Greece. And they are developing a sorting system which allows to extract both plastic and PVC from the waste in order to have a good quality RDF to be used for energy valorization, for example, in the cement industry. I have also included in this slide two more pictures of machines we are developing for extracted components, one on PCBs, for example, or the one below in the right is the mobile sorting system for the paper sectors. We are working on these machines. These are the designs, and we are starting to construct them. Regarding the recycling activity, we have working again with Casale and DDC, which is a technology center from Germany, and in which we are analyzing different wastes from the construction and demolition, as you can see here, and other sources, some slags, industrial waste, some acids, and they are analyzing in order to define if they can be used for clinker or cement production. It's not only if they can chemically be used, but there are different regulations among the countries. So, and if it's not possible to include in the cement, we will work in developing other construction materials. Other example is the green solvolysis based on microwave. In this case, we use glass fiber composites, insulating foam, and woven sheets. The most promising one is the glass fiber composite, in which we are determining the resin ratio in order to extract the fibers of this composite and reintroduce this fiber as raw material for automotive components, wood panels, or composite profiles. Other results we are working is we are trying to define the industrial urban symbiosis concept in the city, establishing a social framework of the Redol, identifying the barriers, analyzing the waste of the maps of the waste resources. We perform a SWOT analysis of the city of Zaragoza, working a lot with the regulatory barriers, which is something that the partners have arisen during these months, and establishing the baselines for the creation of circularity hub. Regarding this circularity hub, we have the 5 value chains, and we have the roles I mentioned before for each partner for each value chains. And we realized that in the first month there were not many interactions between the different partners. So we define a methodology of 4 phases. The first one is the characterization of the stakeholder. And the second is the identification of new collaboration among the partners. The third one, analyzing all the identified opportunities of collaboration. And the phase 4 that is the most interesting is strengthening the integration and the collaboration between the different value chains. In the first one, it was time consuming because we made a lot of interviews with each value chains. We described the role of each partner role and the processes of each partner in order to have the knowledge of the global picture of the partners of the project. In the second one, we identified new collaboration between the different partners. So in order to increase the synergies between the partners, it was surprising to discover new synergies between the different partners of the different value chains. And for analyzing all the identified opportunities, we create some work groups and develop some templates in order to collect all the information and all the results of this workshop. And finally, what we want to do in Zaragoza is to strengthen the integration and the collaboration, carrying out some workshops in order to involve not only the partners, but beyond the Redor project to other stakeholders, if, for example, the regional governments, which are not included as partners, and identify some specification in some legislative axis, social axis, economic, logistic, and organizational. This is the structure of the governance for this hub, where it's needed a coordinator which acts as facilitator and lead the meetings, manage the information. It's also necessary a value chain leader and some meeting between the key stakeholders and the different working groups. And I gave you some brushes of the project that you can follow us on network. You can go to our webpage. We have been quite active. We have organized some workshops. We have been participating in conferences, in fairs, and in the press. So I encourage you to follow us. This is the webpage, and that's all from my side. Thank you for your attention.
I don't know if there are any questions in the chat from the people online. No, don't think so. Someone here? Does anyone has? Yeah, we have a question.
Thank you. I was wondering, what are your plans in terms of dissemination of this project in terms of, let's say, training of the population? I don't know if this is as a role in the first part of the collection of the wastes.
We are defining some targets. I'm sorry. The activities of training have started some months ago, and we are defining in the first months of the project some targets of population in the area of Zaragoza as I mentioned, as targets to have this social awareness. We have the Zaragoza Council, which it's interesting for them to have these workshops or these seminars, but in this case, the training is focused on the region of Aragon, of just training as social awareness. So in order to encourage them to recycle, to know the different value chains, to know not only the technologies developed, but just to this social aspect of the project. Of course, there are a lot of technologies, a lot of partners, and we will disseminate it in conferences, in technical papers, and so on. You're welcome.
Thank you very much. If we don't have any other question, I will leave the floor to the last speaker of today that is connected online. So welcome to Andras Borsits. Many thanks for being here, even if online. So in the meantime, as I did with with the other speakers. In the meantime that we upload the presentation, I would just introduce you briefly. Andras Borsit earned a Master of Science in Woodworking Engineering. In 2023, he joined the Reglass team, where he's responsible for initiating the PVB film recycling business. He participated in the commissioning of the technology at the PVB film utilization plant and actively contributes to its technological development during the testing phase. So Andras also manages the operations of another glass waste processing company owned by Reglass. So many thanks for being here, Andras.
Welcome everyone. Thank you very much to the opportunity to present our company and our work. First of all, who we are and what we make, and how we come to PVB recycling. We have more plants in Hungary, two glass treatment centers, and we have two collecting points. One of them in the west part of Hungary in Mezős. Here collecting with from the region some glass, and the main part of flat glass coming from these collecting points. The other collecting points is in Budapest, in the main town from Hungary. They are collecting we also only container glass, and the newest member of the Reglass family is the GVR, a glass waste recycling company. We started here to work last year in November. Same work how we have we in Orosháza, where all our headquarters is. They are processing container glass and also with flat glass. Here's some pictures and some data. Our companies. Reglass exists since 2016 and continuously growing. Actually, we are constructed a new process line for fines and reject glass processing. Some short video about our plant. I hope you can see it. It's not so long. The collective system is very, very dirty in Hungary, as there is a lot of contamination in glass waste. We have to 2 times sort manually, and after that can be processing with the technology, with optical sorters. Our main partner is OI, Hungary. All the flint glass selling we to OI, and color glass cullets we are selling to in Europe, Croatia, Italy, Austria. Flat glass collecting. Where does the flat glass comes to our company? We treating mainly only pre-consumer products. that means laminated glaze producer, car windshields producer, and insulated glass producers deliver us their waste. We collecting these three types of material separately, and we are treating and processing because of glass this material. We have an extra line for the processing the laminated glass or flat glass. We are crushing, manual sorting, one more crushing, and after that, drummer sorter will be sorted this material. There is some short video. This process we repeat more times, and after the processing the flat glass, we are coming to 10–15% glass contamination on PVB film. And this PVB film is mainly, here's a video from car windshields processing. The process is the same. The end PVB film, which is contaminated 10–15% glass, yearly will be landfilled. And for 2 years ago, we have started a project. How can we reuse or find a solution? How can we this PVB film recycle? And there is, after 2 years research and development, what was supported the Hungarian government. Last year we are coming to a point we are able now from this waste, maybe 1,000 tons per year, really clear PVB film flake in flakes format to produce. Our biggest challenge was in this project. First of how can we separate different material from the input material. Here is not only glass contamination in this material, but more other plastics. We from laboratory experimental are we coming to a mechanical and chemical recycling process, and we can now produce really clear flakes without any contamination that can see in the picture on the right side. We have partners, they also regranulate our flakes, and we can produce we can produce with dark, but the problem is the PVB foil stick very strong together, and we can with dark avoid it. The biggest challenge no, in this question, we are looking the market for the REPVB. We are contact over Fairware some European partners, and we have a lot of question from Asia, but the price is a difficult question. That's why that was my presentation. Sorry for my English. My main foreign language is German. Do you have any question? Do not hesitate to contact me. My email address is end of the presentation.
Thank you very much, Andras. It was a really nice presentation, very interesting. And as I said, if someone connected online want to ask something, both to Andras and also to the speakers that have already presented, please do not hesitate, do it now. I don't know if someone here in the audience at Los Arcos want to say something or wants to or have a question. We have maybe a question. Hi.
Hello.
Hello.
Thank you very much for the nice presentation. Actually, what you have done is very, very interesting, and of course, interesting to us working on the same field. So I would like to confirm that to me. Is this what you are trying to do goes for what we call closed loop recycling? That is, you are recycling PVB, starting, for example, from windshields or from construction glasses or photovoltaic panels, and I suppose you intend to come back to the same application. This is what we call closed loop recycling. In that case, the quality is something that it is very important. So I would like to ask you if you have any data about the quality of the PVB that you are getting after the recycling process. We think and we share with you this morning that this is an important issue also in our project. So I would like to ask you about the quality of what you are recycling. Thank you.
We let them prove in Hungary our material, and we have a labo tests from this check, and there is free from foreign material because of glass. 90 over 99% clear. We have some problems with yellowness. That means we can't use for original purpose. Actually, but the newest products can we not tested. It's in progress, but the old tests results can I send you if you want.
Thank you very much, Andras.
You're welcome.
Other question? No, maybe not. Also online, there are no questions. So If you have not any other question, I just want to remind all people that Sunrise Project is online on the main social platform, on LinkedIn, on Twitter, and also on YouTube. So please go on your account and follow our project because the project will end in November, but we have other events, other news to give you. So if you would like to follow us, you will find all our news and all our events that will come in the next month, and you will be always updated. We have also a newsletter, so if you want, you can go on our website and subscribe. I just also want to inform you that next week you will receive a survey to fill in because we would like to ask for your feedback related to our results. So I just kindly ask you to fill in our form, spend just a couple of minutes to fill in our survey and tell us your feedbacks and your opinion about our innovations, our technical activity. Thank you very much to the people online. For you, the event is over. We will continue our event here in Lurederra, visiting the facilities. So thank you very much for being here. And I hope to see you in our next event that we will organize during the last day of the project. Many thanks and goodbye. Okay. So now